right, so we're going to look at some review problems over our extension review chapter 4. So this first problem, it says to find a polynomial in factored form of degree 7 such that 3 is a 0 of multiplicity 4, 0 is a 0 with multiplicity 3, and f of 2 equals 10. This is a problem that's on your review packet that everyone seems confused about. So let's talk about what it means to have a degree of 7. A degree of 7 means I have to end up with x to the 7th power as my highest exponent. So I'm going to start the problem by writing y equals. Now it tells me that 3 is a 0, so as a factor it had to have been x minus 3. If it has a multiplicity of 4, what do I put as my exponent? 4. Multiplicity of 4 means that this is going to be a solution 4 times. Then it tells me that 0 is a 0. What is the factor if 0 is the answer? Just x, right? So it's just x. And it says 0 is a 0 with multiplicity of 3. Okay? Anytime something is a 0, x minus that number had to be a factor. So x minus 0 is just going to give us x. So now I know that I've got this. But it also tells me that f of 2 equals 10. That means that there's some a value here. All right? And I have to figure out what this a value is. So to figure out this a value, I'm going to use this information. So this would be telling me that when y is 10, x is 2. So when I figure this out, I'm going to have 10 equals, this is negative 1 to the 4th, that's just 1. 2 to the 3rd is 8, so I'd have 10 equals 8a. And so a is going to be 10 over 8, and that is going to be 5/4. So this would be my function then. It doesn't tell me what to call it, so I'm just going to call it y equals 5/4 x minus 3 to the 4th x cubed. You can have the x cubed first. In fact, that might be a little bit better. But here we go. We've got multiplicity of 4 on this one, multiplicity of 3, and the total degree is 7. So this would be our answer. All right, down to number 2. A lot of people have trouble when we have a factor like 20. What you want to do is break that down into its factorization. 20 is 4 times 5, so this is going to be 2 times 2 times 5. Before I deal with the variables, I want to see if they would cancel. So if I have y to the 10th over y, this could just become y to the 9th. That makes it easier. And this y would now be gone. So if I have 2 times 2 times 5 times x to the 4th, well, in order to take one out, it has to be a factor 3 times. Okay, so before I even start, I'm going to do this. I'm going to do cube root of y to the 9th. I can actually do that. So that's going to be y to the 3rd. I can't do the 3, so this is cube root of 3. And then on the bottom, I can go ahead and take the cube root of x to the 4th. I can take an x out, because I know the cube root of x to the 3rd is just x. And then I would still have 2 times 2 times 5, and there would still be an x in there. So in order to get this completely simplified, I need 1 more 2, I need 2 more 5s, and I need 2 more x's. So I'm going to have to multiply by a 2. I need 2 more 5s, so that's 25, and I need 2 more x's. I have to do that to the bottom. So I'm multiplying the bottom by 50x squared. So I have to do that to the top, the cube root of 50x squared. So now what I'm going to have is I'm going to have y cubed on top. I'm going to have the cube root. This is 150 x squared. And then on the bottom, I've already got an x. I have 2 times 2 times 2, so a 2 comes out. So that's going to be a 2x. And I also have 5 times 5 times 5, so a 5 can come out. I've got x times x squared, that's x cubed, so an x can come out. So here would be my final simplified answer. And sometimes people think, well, what about that 150? Can't that be broken down? Well, that's going to be 50 times 3. So nothing, 50 times 3 is going to be 5 times 5 times, times 2 times 3. So there's nothing that's 3 of a kind, so nothing can come out of there. That's all we can do. Okay, for these problems, we have to understand that a squared minus b squared is always going to be a minus ba plus b. So this is just going to go down to, this is my a, plus b, and then it would also be a minus b. The only thing tricky about this one is simplifying this now. So if it's addition, I don't have to worry about it. It's just going to be x plus y minus 1. But over here, this is subtraction, so I have to make sure I distribute the negative. So it's minus y and plus 3. So I'm going to have x minus y, and 2 plus 3 is 5. So I'm going to end up with that. This one, they showed us how to group it, but even if those parentheses weren't there, we should recognize that that's something that we can factor. How does that factor, you guys? Right here. What is this? X plus 3 squared minus 49y squared. So now again, we have a squared minus b squared. So this is going to go a plus b, a minus b. It's not so bad. For this type, we want to think of a u substitution. It makes it a little easier. I'm going to think of u or y or whatever variable you want equals 2x minus 3. So now my problem is u squared minus 5u plus 4. So factoring this, I would need numbers that multiply to be 4 and add to be 5. That's going to be 4 and 1, minus and minus. And so now I'm going to have 2x minus 3 minus 4, 2x minus 3 minus 1. And so that's 2x minus 7, 2x minus 4. And then out of this one, I can also factor out a 2. So I need to take another 2 out of this one. And so this would be my answer. For this type, set up your double parentheses. This is x to the 2n, x to the 2n. Numbers that multiply to be 9 and subtract to be 8 are 9 and 1. And this is going to be a minus, this is going to be a plus. Well, this can get factored down further. This is x to the n minus 3, x to the n plus 3. This one we can't do anything with. So just be that. On the next kind of problem, what do we have to do on this type when we're multiplying? Get like, what? Bases, right? So 27 is 3 to the third. So I have 3 to the third, and then I still have that x plus y. This is going to be 3 to the second, and we still have the x minus y, and then just 3 to the x. So we get this. And so now my base stays the same, and I'm going to add these exponents. So 3x plus 2x plus 1x is 6x, and then 3y minus 2y is plus y. And so this would be our answer right here. For this one, for this function, what are the possible rational zeros? When it says possible rational zeros, that's where we take the factors of the last term, ignoring the negative, so plus or minus 1 and 5 over plus or minus 1 and 3, and then we have to write out all the possibilities. Hello. Okay. All right, thanks, bye. Jessica, you need to go to the annex. So now we're going to have plus or minus 1 over 1 is 1. 5 over 1 is 5. 5 over 1 we already did. 1 over 3 and 5 over 3. So plus or minus, all of those are going to be our solutions. So we could have 8 rational zeros. Any of these 8 could be a solution. The next thing is, what is the maximum number of positive real zeros? See, look at the difference here, guys. This is rational zeros. This is where we do the P over Q thing. And then how many do we have? We have 8 of them. But to find the maximum number of positive real zeros, this is where we do Descartes' rule of signs. And we look for the number of sign changes. We have 1, 2, 3. So we can make this chart. We could have 3 positives. Okay, now I have to plug in a negative. So the maximum number of positives is 3. To find out negatives, I have to plug in a negative for x. A negative to the 4th is positive times 3 is positive. A negative to the 3rd is negative times negative is positive. That's going to be positive, and that's negative. So 1. We can only have 1 negative because we can subtract 2, but if we subtract 2, it doesn't make sense here. So one possibility is 3 positives, 1 negative, no imaginaries. But I could also subtract 2 from this, and I could have 1 positive, 1 negative, and 2 imaginaries. These imaginaries have to occur in pairs. But the minimum number of negative real zeros I could have would be 1. And then is the function even or odd? I can just look at the exponents. If all of my exponents are even, it's even. If they're all odd, it's odd. This has a degree of 4, that's 3, that's 2, this one's 0. So it's a combination, so it's neither. All right, any questions over all that? Okay, so that should help you with those reviews on chapter 4 that you're working on now.